we have r equals 5 cosine 4 theta. And I'm just going to use the shortcuts here. I'm not going to draw the actual big graph here. So let's see, it's 4, so that means there's twice as many petals. So this is going to have 8 petals total. The angle in between those petals is 360 divided by 8. That's going to be 45 degrees in between them. My max radius is going to be 5. And this is cosine, so I want to figure out where we start with that. Cosine always has a maximum at 0, so I just set for theta equal to 0, and I will get theta equals 0. So I can go about plotting this now. Let's see, I have radius of 5, so I'm going to find the first starting one. Go 1, 2, 3, 4, 5, that's way out here. Now I just go 45 away, 45 away, 45 away, 45 away, 45 away, 45 away, 45 away. And then I can just come here and graph them. So this is not how it's actually graphing, and that's super important in real life, and there's no overlap here. But since I can't tell in a finished version what yours would look like, you can graph it in any order you want. I think officially what it would do is start here and go to this one, and then come up here and does some weird stuff. We could put it into graphing software to really see what it looks like, but that's a done version. Done. It's not that bad when we use the shortcuts. Next we got r equals 5 sine 4 theta. Okay, so this one is still going to have 8 petals. It will still have 45 degrees in between all of them. It has a max radius at 5 still. So it's the start that's going to change because of sine. So sine has its first maximum at pi over 2. So I'm going to set 4 theta equal to pi over 2 and solve. That's going to give me pi over 8. It would. So pi over 8 is like maybe 22-ish degrees, and these are going by 15. So I'm just going to kind of estimate that it's about there, and then I believe it's going to be about here, and then I'm just going 45 away for each one, trying really hard not to mess up, putting these dots in hopefully the right spot. Okay, then I'm just going to connect them in any old order. Again, there is an actual way that they connect, which is super important, but for us, we don't really care about it right this second. There we go. Here's our comparison. They both have 8 petals. The only difference is that they start in different places. Cosine, which has its first maximum at 0, always wraps around the x-axis. Sine, which has its first at pi over 2 normally, is going to shift off of the axis and have its first one somewhere in the first quadrant. Next, we got r equals 10 cosine 3 theta. All right, so it's odd, so that means we're going to have exactly 3 petals. That means that they are 120 degrees apart from each other. Our max radius is going to be 10. It's cosine, so when it starts, it's going to start at 0 degrees. So I'm just going to assume my scale is by 2s here. So I put my first one here. I'm going to go 120 away. So that's going to be right here. Go another 120. That's right there. And I'm done. This one wraps itself there, there, and there. Each one 120 apart, maximum radius of 10, 3 petals. There you have it. Last but not least, r equals 10 sine 3 theta. So odd, so we have 3 petals. 360 divided by 3, that's going to be 120 degrees. So that's how far apart each petal is. The max radius is going to be 10. Our start is going to be what's different. So it's a sine, so we do 3 theta equals pi over 2. So I'm going to have theta equals pi over 6. That's my starting point. Okay, so that's 30 degrees. I'm going to again pretend my scale is by 2, so there's my first one. And I'm going to add 120 degrees. That's going to be there. Add 120 degrees, and that's going to be right there. So this is the completed graph. Okay, so again, they're very similar, just that their starting points are different. So rose curves, not that bad.